Hi everyone, so today we are here with a new problem. This is a Leetcode medium problem which is populating next right pointer in each node 2. So the way we are going to solve this problem is first we understand the approach, the problem, and then we see two approach to solve it. Stay tuned and let's see what is the problem first. So the problem is basically populate each. So basically we are given a binary tree, okay, and that binary tree contains node are there, and each node have value left, right, and next. There are 3 pointers with each node, okay, and there is one value with this node. So what we have to do is populate each next pointer to point to its next right node, right? So each node contains the next pointer, and that next pointer should represents the right node, okay. If there is no right node, the next pointer should be set to null. As simple as that. What it means, let's understand this by a test case. So as you know, this is a binary tree. This binary tree have left, right. These two have 4 and 5 as left, right. These 3 don't have left, but it contains right. Now for this node, if you see at its right, there is no node. So for this, the next pointer is pointing to the null, right. For this 2, there is 3 as a right node, so its next is pointing to this 3. And for this 3, there is no right node, so it is null. For 5, for 4, this is 5 as right. For 5, 7 is right. For 7, there is no right, such that it is null, null, and null. And we have to do this. Very great. Now how we can do this? Okay, you can pause the video and think about it, how we can do like these things. Okay, now let's come to the problem solution. So as you know, what we are doing at each level, whatever the nodes we have, we are just make their nodes next to its right node, whatever it is. Okay, so like this is the level 1, this is the level 2, this is the level 3. For this level you can see there is only one node, that's why it's next, not pointing to anything. But there are 2 nodes, so the first node is pointing to the second node, and if you see the first node pointing to second and second one is pointing to the third one. So we basically use the level order traversal. How we are going to use it, let's see this by taking this example. It is very simple. So what we do initially we will take a queue, right, and we will take this one and put it in our queue. Now one thing you have to understand, let's suppose you are at level 1. When you are at level 1, you always try to make connection between the level 2, and when you are level 2, you always try to make connection between the level 3. Okay, so whenever you are at some level, you always try to make connection in its below level. Now let's see how we will do this. So let's suppose we are at we are pushing the current node to this point. So what we will do, we will take, what is the size of this queue? This is 1, and as you know, at each level, whatever the first node for each level, that is the first node which start make connections for the rest of the nodes, right? For the first node, there is no connection between the first node. Like for 2, there is no such node which is connected with this. For node 4, there is no such node which is connected with this, right? So what we do, we will take a node, and this node is what we take it out from the queue, so it is 1, right? Now what we do is we basically check if this node have left and right. So you can see that 1 has left 2 and right as 3. So we will push 2 and we will push 3. Now we will make a for loop for the rest of the elements at the level 1. But you can see there is only one element, one node in the level 1, which is we already take it out, and that's why we are not able to iterate for the next of the road. Just wait, let's see for the next road, you can understand more clearly. Okay, now we will again go to the queue and we will check the size. So now the size is what? The size is 2, so we will write 2, and the node is whatever the first element present in the queue, which is 2, so we will take it out, which is 2, and for the 2, left and right should be pushed, which is 4 and which is 5. Now 1 is already used, the size is 2 and one node is already used, so there is only one node left, which is 3. So what I do is I basically remove this node, which is 3, and what I do, I will make this 2 is pointing to this 3. How? We can write like node dot next is equal to this current. What it actually do, it actually make 2 dot next. So this 2 dot next is actually 3 is current, right? And after this we will check if this current contains left, no. If it contains right, yes, 7, so we will push 7 into it. Great. And after that we will also update the current, sorry, not current, node is equal to the node dot next, right? So node is 2 and 2 dot next is 3, so now my node is pointing to the 3. Okay, but there is only one element, 2 element in the level 2, so this iteration stops. Okay, we will work for the next iteration. Now for the next iteration, what we do, the same thing, we will take the size. Now the size of q is what, 3. Okay, and for the first node of this level, we will take it out as node. Okay, so we will write 4. And now what are the rest of the elements? Rest of the elements are 2. So what we do, we will make a current, and the current is whatever we pop it out from the queue, which is 5. Now we will do what? We will do node dot next is equal to the current. So node is 4 and 4 dot next is equal to the 5. And is there any left and right for this current? No, 4 is a leaf node, so we don't push anything in this stack. After this, what we do, we basically update our node is equal to the node dot next, right? So node dot next is 5, so my node is pointing to the 5. And again I pop from the thing and it is 7. Now what we do, node dot next, so what is node? Node is 5. 5 dot next is current, which is 7, so 5 is pointing to the 7. And we will also update this, so now my node is 7. And you can see my whole array, my whole queue is empty and there is no other element here, so we don't push into the queue. And at the end there is like every node next pointer is populating with its right node. So I hope you get this, how we basically solve it using queue. But here the space, extra space we are using, we go off, and whatever the number of nodes present in this binary tree, all these are pushed inside this queue, and that's how we are going to solve it. This is the approach one, okay, and this is very good approach to solve it. Now how we can solve it using without queue? Okay, so the second approach is with the help of pointers. So we are using pointers to solve it. But how? For that you have to understand a little bit how we basically solve the previous problem, okay, and then we can understand from those. Let's see. Let me rub it. Great. Okay, now you can see what we are doing inside the queue. Let's suppose we are at this node, so we basically store all the level 2 things in our queue, and this, the first node of each level, we use as an initializer, okay, and whatever the next node we are getting in this level, we just make connections. To solve it, we are using some pointers, okay, and let me write the pointer name and then we'll tell you what we are going to do with this. So the first pointer we take is previous, which is initially none. The next pointer we take is current, which is also none, right? So it is like this. Not current. We basically take a head. I will tell you everything. Just a minute. And there is one more node, which is a current, which is initially the root. Okay. Now this previous, what this previous is doing? So this previous is basically the pointer. So let's suppose we are at the level 2. So what we do is we basically are at this level, and for this first node of level 2 we use the previous pointer, which points to this, okay. And let's suppose at any point of time, okay, let me rub it. Let's suppose for this level 2, if my previous, this thing is none, it means we are at the first node of this level, okay. We will understand the whole thing, but this previous is just a pointer for all these nodes in each level. This head is basically tells us for each level what is the first node. So this head is pointing to the first node of each level, and this current is telling us in which root, in which node we are in, and which node we are iterating in, okay. So initially my current is root, so root is what, 1, okay. So what I do is, let me take a different color. So what I do is, I'm at this node and we will make a loop until my current is none, okay. So what we do is, we are at the root node, right? We will check if my current left is there. You can see that for this current there is a left node, right? Then we check, is my previous is none? Yes, it is none. So if previous is none, it means that this is the first node of our level, okay. So if it is the first node of our level, what we have to do, we simply initialize this previous with 2. Now my previous is pointing to this 2, right? And my head is pointing to this 2. Why? Because if it is the first node of this level, so it means this is the head for this level. That's why we are updating our head. Now we will check if my current right is there. Yes, my current right node is there. And we also check, is my previous is none? No. And that's how we come to know that my previous is initialized with the node, right? In that case, when my previous is not none, what we do, we will make a connection between previous equal to current dot right. So current is 1 and its right element is 3. So what we do, we will do previous dot next is equal to the current dot right. And this is the first pointer, first next pointer we create. And after this, we will update our previous with the 3, right? So we'll update it with 3. Now you can see after this, if whatever my current, it is 1, and I will check is there any other node in this level. So we are at level 1 initially, right? So we will check is there any other node in the level 1 that we can iterate, and you can see there is no other node here, right? So in that case, what I do, I basically update my current with head. So my head is pointing to the 2. So now we are at level 2, and when we update our current, we also update our previous with none and head with none. Now we are at this and my current is 2, so I will check that 2 have left node. Yes, it contains left node, and when it have left node, we will check previous. So previous is none, it means it is the first node of this level. Yes, it is, so we will update it with 4, right? After that, we will check this current contains any right. Yes, it contains the right node also. So in that case, my previous is not null, and we also update our head. Okay, that is the important thing. Now you can see that our previous is not null, so what we do, previous dot next equal to current dot right. So this 4 is connected with this 5, and also we update our previous with 5. Great. Now you can see this current is 2 and this 2 dot next. So 2 dot next is 3, so we are update our current by 3. So now we are at this position. So you can see 3 don't have any left element, so we will do anything, but this 3 have right element. So this 3 contains the right node, and the previous is not equal to none. In that case, what we will do, we will basically make connection with 5 and 7, this thing, and after this we also update our previous with 7. Now we will see the 3 dot next, which is none. There is nothing in the next, so our current is none. Now we will update our current with the head. So what is the head? Head is 4, right? And this previous is none, and this head is none. Now you can see this 4 don't have any left right node. So what we do, we simply check its next element, which is 5. So there is no node, it is a leaf node, so we go to the 7, it is also a leaf node. Then we update our current with our head, so which is none. So whenever current is none, this loop stops, right? And this whole connection is completed, right? And that's how we are going to solve this problem more optimally without using any extra space, any extra queue. Now let's see the code, how we are going to solve it. It is very easy, as I explained you. So this is the base case. If the root is none, we have to return. Otherwise, there are 2 nodes, head, previous, and current, right? So what we will do, until our current is not none, we will go through this. So what we will check, if our current have left value, and in that case, if my previous is not initialized, right? If it is not initialized, it means this is the first node, so we make our head as current dot left, and also update our previous. Got it? And we will check if it contains the right node, and my previous is not initialized, we will do the same step, we just initialize it. And if previous is not none, it means it is already initialized, then we will populate its next pointer with the right one, and also update our current with current dot next, right? And let's suppose this is the code for each level, and when one level completes, we will make our current with equal to head, and head and previous is again initialized with none, and then again we will do the same process for the next level, and we will do until all level is traversed, and hence at the end of the day we will returning root. So let me submit it, and yes, it gets submitted. And I hope you like this problem, and if you like this, please like, share, comment, and you can tell me how I can improve these things. Thank you.